Hello student, today I am going to discuss very important topic which is nothing but a concentration terms. Last class we discussed the stoichiometric related problems. Now I am going to discuss that concentration terms because this basic concept of chemistry is composed by several important things which is nothing but a mole concept is there and different way calculations of number of moles is there, stoichiometric related problem is there, then concentration term is there, as well as laws of chemical combination is there. These are the basic thing. Again for JEE, this chapter will be connected with a redox part that we will discuss. You need not to worry. Now you look at today our topic is discussion of a concentration term. So concentration term, concentration term. So when we are talking about the concentrations, then it is coming to the mind everybody's, it's about solutions. Definitely solution can be different in second year topic. Solution itself is one chapter is there, we will discuss in detail. But solution means what will be the scenario will be the solution means generally there are two parties there, everybody knows. One part is called as a solute and other part is called as a solvent. Generally the solute is nothing but a lesser part of a solution. This is a lesser part, this is your lesser part, and whereas solvent is a larger part. Yes or no? Everybody knows. So solution has a two part. What is that? Solute and solvent. Solute is a lesser part of a solution, whereas solvent is a larger part of a solution. And as we are going to discuss the different concentration terms, we need to know solution, because concentration means what? The solute, how much present in a solutions, based on that we will describe the concentration terms. Because the solute whenever is there are different types of solute is there. Like if I give different type of example, and solution, you know, there are different solution are possible. Liquid plus liquid, that means liquid solute, liquid solvent. Then liquid solute, your gaseous solvent, gas possible, solid gas possible, solid liquid possible. Generally whatever we will discuss over here, that will come under that category where the solute is solid and the solvent is a liquid. But it can be any composition is possible, which we will discuss in detail in solution chapter. Now if you look at that, your solute has a different types of nature, like NaCl. If your NaCl is solute and solvent, I am taking you like that. Here suppose I am taking H2O. This is your solute and this is your solvent. Whenever NaCl will give into the water is a solvent, then NaCl undergo disso. Disso means what? Dissociation. Then if I take acetic acid, okay na, I am taking acetic acid. Suppose I am telling this is your solute, and this acetic acid I am taking in solvent, I am taking in benzene. Benzene everybody knows, C6H6. Okay na. Now you look at this acetic acid in benzene, it will undergo association. Association. This is dissociation, this is association. Whereas if I take glucose, glucose is your solute and solvent is a water. So this is, I am telling Na means any non-electrolyte. Na means non-electrolyte. That means it will not undergo dissociation, not undergo association. So here mainly we are discussing about the solid solute and the liquid solvent. But the solute has a different tendency into the solvent. One type of solute is there, they can undergo dissociation. One type of solute is there, in a particular solvent, they can undergo association. Another type of solute is there, they will not undergo association, not undergo dissociation, they are like a non-electrolyte, like a glucose, urea, sucrose, they are non-electrolyte. Depending on this nature of the solute, the scientists developed the different concentration term to define a solution. Why concentration is required? To define a solution. So now what are the concentration term is there? First we need to study concentration term, which is nothing but a molarity, which is denoted by capital M. Second, we need to study molality. Molality. One is RITY, one is LITY. One is denoted by capital M, whereas other one is denoted by small m. Then third one is nothing but a normality. Normality, which is denoted by capital N. Before going to detailed discussions of normality, I will discuss the equivalent concept which will be utilized especially in the normality. Okay na? So now next one we need to know weight by volume percent. Next one we need to know weight by weight percent. Next one we need to know volume by volume percent. Next one we need to know ppm, parts per million, and ppb, parts per billion, as well as another mole fraction terminology, mole fraction and molarity, that also we need to know, mole fractions. So these are the different things we need to know regarding the concentration term. Why? To define a solution we need a concentration terms, as simple as that. Why these concentration terms are required? Here I am writing to define a solution. To define a solution, we need a concentration term. And what are the different ways of concentration term is there? Molarity, molality, normality, weight by weight percent, weight by volume percent, volume by volume percent, mole fractions, all those things is there. Why scientists develop this much of thing? Because generally we used to considering over here, solute is a solid and the solvent is a liquid, and the solute has a different nature is there. One type of solute will undergo dissociation, one type of solute will undergo association, another type of solute not association, not dissociation, as it is, it's nothing but a non-electrolyte. Based on this different nature of the solute, the scientists develop the different ways of concentration term to define the solution. Is it clear? Okay. So let us start with that. Today's discussion with a molarity. It's a very important concept. It will be utilized in lot of places. In equilibrium chapter it will be utilized. It can be utilized over here. Even this topic will be discussed, can be connected with a mole concept. Whenever pH calculations will be there, this term will come again. So that's why this molarity, definitely almost every year or alternative year, if you look at JEE Mains, JEE Advanced, from molarity concept, question is there directly or indirectly. That much importance is there about the molarity. Okay, let us look how we will discuss about the first. Our concentration term is nothing but a molarity. Okay, so let us look at molarity. Molarity. What is molarity? Which is denoted by capital M. Molarity will be equals to, mathematically, this is a number of moles of solute, number of moles of solute by volume of solution in liter. Volume of solution within bracket in liter, which is I am represented by V. That means M equals to N by V, where N is a number of moles of solute and where V is a volume of solution in liters. So molarity will be equals to number of moles of solute by volume of solution in liter. So then molarity into volume, m into v is nothing but a what? In. That means molarity into volume of solution in liter, volume of solution in liter is nothing but a n, which is nothing but a number of moles. As simple as that. Same way, molarity into volume of solution in ml means milliliter, in ml will be equals to number of millimole. Then what is the relation between millimole and mole? You know very well. What is the relation between meter and millimeter? Exactly same. So then immediately I can write down 1000 millimole equals to 1 mole. And if you look at, if millimole is giving, if you want to convert millimole to mole conversion, millimole to mole conversion, what you have to do? You have to do equals to what you have to do? Millimole divided by 1000 will be equals to your number of moles. And same way, mole to millimole conversions. Mole to millimole conversions. Which will be equals to, in this one we discussed millimole to mole conversion. Whatever millimole is there divided by 1000 is a number of moles. Now mole to millimole conversion. Previous one millimole to mole conversions. Now mole to millimole conversion. So then what you have to do? Whatever mole is there multiplied by 1000 will be equals to number of millimole. Is it clear? That means as simple as that, whatever millimole is there, simply divided by 1000, you will get a number of moles. Whatever number of moles is there, multiplied by 1000, you will get a number of millimoles. Is it clear? Huh? So now, this is the idea we know. And mathematically, molarity is nothing but a number of moles of solute by volume of solution in liters. And we know how to find out the number of moles. In mole concept we discussed. If n is your number of moles of solute, what are the way we can define the number of moles? In terms of a number, given number by Avogadro number. In terms of a mass, given weight is W divided by molar mass. In terms of a volume, given volume by 22.4 liters. This volume also should be in liters. Here this is gram, this is gram. So this way we can easily find out the number of moles. These are the ways we will find out the number of moles. And once we get the number of moles divided by volume of the solution in liter. If it is there in ml, then ml divided by 1000 means volume of the solution in liter. Yes or no? Very simple idea. Mathematically, number of moles I will find out either any one of this way, and volume of the solution, if it is there liter, that value directly I will put. If it is there in ml, I will divide that volume by 1000, then I will get in liter, that I will put and I will get the molarity value. As simple as that. Now, next point, is molarity depend on temperature? Is molarity, here I am writing, is molarity depend on temperatures? Depend on temperature. Your answer will be yes. Why is molarity depend on temperature? Because whenever volume term will be associated, you look at, if you increase, there is a one sugar solution is there. If you heated up that sugar solution, what will happen? Slowly, what is the liquid part? Generally water. Suppose sugar is there in a water. Then when I am heating up, then my solvent means solution volume part will decrease because solvent will go out in the vapor form. So that's why whenever my temperature, here itself writing, whenever my temperature increases, volume of the solution decreases, and volume of the solution decreases means molarity will be what? Increases. This style is a competitive teaching style. Temperature increases, volume decreases, molarity increases. Yes or no? So that's why we came to know whenever temperature increases, then volume of the solution, denominator decreases means overall value will be what? Increases. Even physically you can think, when we are increasing the temperature, then from the solution volume is decreases. More water is going out from the solution in the form of a vapor, then solution getting more and more what? Concentrated. That means molarity is what? Increases. So, whenever temperature increases, volume of the solution decreases, molarity increases. So, that's why whenever any concentration term, if volume is associated, definitely that will depend on temperature. Based on that, there are some books, they used to categorize temperature dependent concentration term, temperature independent concentration term. I give you simple logic. You just apply wherever there is a volume term associated, SAT told definitely it will depend on temperatures. Is it clear or not? Okay, this is about the molarity. First, the aspect of molarity, how to define, we discussed. Now, we will go to the different types of model problem. Then you will confident and then we will bind up. Let us look at the first problem. Suppose if I am telling 20 gram of NaOH dissolved in 250 ml of 250 ml of solution, and this is water based solution. I am telling water based, and here I am telling conditions also. For dissolving NaOH, not changing the volume of solution. Always this part you have to remember, not changing the volume of solution. Then simply we will do. You look at how we will do this problem. This is some basic problem, board level problem, not even board level problem. Very simple problem we started. I told you molarity will be equals to capital M, number of moles of solute by volume of solution in liter. N is a number of moles of solute by volume of solution in liter. Volume of solution in a liter. So that is nothing but your molarity. Now first I need to find out mathematically number of moles. By the way, all element of atom, especially 1 to 30 and few other element like a lead, like a iodine, like a bromine, like a chlorine, like a few transition metal, chromium, manganese, copper. So all those atomic weight you have to remember. So then only that molar mass, if unknown thing they are giving, some they used to supply in the question. But sometimes if it is not supplied, so that you should not stock over there. Point is clear or not? So that is the idea over here. Now you look at, so first we need to find out number of moles of solute. Number of moles of solute, which will be equals to, how you can find out? Here they are giving mass. In terms of a mass, what I told? Given weight, which is W. This is given weight. Given weight in gram divided by molar mass of the substance. These also will be in gram. Then we will do that things. Given weight of NaOH, here NaOH is a solute and water is a solvent. So now here given weight of NaOH which is 20 and molar mass of NaOH is 40. Sodium is 23, oxygen 16 and hydrogen 1. So then if you add it up, it will comes to 40. So then 20 by 40, which is nothing but a half mole. Yes or no? We got the number of moles of solute. Then volume of the solution in liter I have to take it now. Then V is a volume of solution. Volume of solution. I have to take it in liters. So immediately what I have to do, whatever ml is there, I have to divide it by 1000. ml to liter conversion divided by 1000. So that's what I did. So now I will do molarity. Molarity will be equals to mathematically number of moles of solute, which is half, divided by volume of the solution in liter, which is nothing but a 250 by 1000. After that calculation, you are master on this. So you will do like this, 1 by 2 into 1000 will come over here. Here is your 250, 254. So then this will be nothing but a 2. So that means if you look at over here, then your molarity is coming how much? 2. That's why this solution is a 2 molar solution. 2 molar will be your answer. How to write down? 2 molar within bracket. Got the thing? Is it clear? Very simple. We just calculate the number of moles of solute by doing given weight by molar mass. Volume of the solution I converted into liter, ml divided by 1000. Then number of moles of solute by volume of the solution in liter. Number of moles of solute will be there in a numerator and volume of the solution in denominators. So then you will get that value. Is it clear or not? Okay. Let us look at the next problem. Next problem, what I am telling, to prepare 250 ml of 0.1 molar oxalic acid. Here I am giving you, this is called oxalic acid, COOH, 2H2, and 2 molecule of water of crystallization is there. This is a oxalic acid. Anhydrous means this water will not be there. This is oxalic acid. To prepare 250 ml of 0.1 molar oxalic acid solution, how much amount of oxalic acid are required? Oxalic acid are required in grams. Is it clear? Now you look at, here they are giving in a reverse. Molarity is giving amount of the substance they are asking. So if you know forward process very well manner, then you can come in a backward process. That's all only we will do. Now you look at, here they are giving molarity. Now first you write down what is the molar mass of oxalic acid, including these 2 water of crystallizations. If you look at 2 carbon, 2 carbon means 2 into 12, 24, 4 into 16, 64, 64 plus 2 hydrogen, 2, 66, 66 plus 24, 90, 90 plus 36. That means 2 moles of water. 1 mole of water is 18 gram. 2 moles is 36 gram. So that's why 90 plus 36, which will give rise to 126 gram. That is a molar mass of oxalic acid, 126 gram. Now they are asking, I have to prepare 250 ml of 0.1 molar. Here itself another important point I am telling you, just remember always, if they told decimolar solution means they will give like this, m by 10. M by 10 how? They will write down 0.1 molar. This point. Whenever they will say decamolar solution, decamolar solution means you need to know it is nothing but a 10 molar solution. Semimolar solution means it will come in a different problem. Semimolar solution means m by 2. Then Centimolar solution means centimolar solution. Centimolar solution means m by 100, and millimolar solution means millimolar solution means m by 1000. These things always you will remember. What is that? I told this is the things always you have to keep in mind. Decimolar solution means m by 10. They will represent like this, which is 0.1 molar. So decamolar solution means 10 molar solution. Semimolar solution means m by 2, and centimolar solution means m by 100, and millimolar solution means m by 1000. Is it clear? Now, in this problem, they are telling we need to prepare 250 ml of 0.1 molar oxalic acid solution. How much amount of oxalic acid are required? So now that my molarity, we will do directly basic method. Molarity will be equals to number of moles of solute by volume of solution in liter. Molarity provided, volume of the solution provided. I will first find out the number of moles of how much oxalic acid is required. Molarity, how much I need to get? 0.1. Then number of moles of solute means oxalic acid, N, by volume of the solution 250 ml, but volume of the solution should be in liter, that's why 250 by 1000. Then immediately what I am getting? 0.1. N is a number of moles of solute, which is nothing but a number of moles of oxalic acid, because here oxalic acid is nothing but your solute. So then 250 into 4, then number of moles will be equals to 0.1 divided by 4. So which is nothing but a 1 by 40. This is the number of moles is coming. Yes or no? So now again we know they are asking the how much amount, mass. Then number of moles in terms of a mass given out by molar mass. Number of moles, how much I need? 1 by 40. How much given amount, that is they are asking. W they are asking. Molar mass is 126. Then W will be equals to 126 by 40. This will be your answer. You can simplify this one. You look at how we did. This problem was there in a reverse manner. They are asking to prepare a 250 ml of 0.1 molar oxalic acid solution. Obviously, it's nothing but a 2 water of crystallization is there with oxalic acid. And then they are asking how much oxalic acid required in grams. Simply what I did, molarity equals to number of moles by volume of the solution in liter. Molarity value provided. Volume of the solution given in ml, I just convert in liter divided by 1000. Then after that calculations we did. Here you look at 1000 go up, 250 in 4, then number of moles is 0.1 by 4, which is nothing but a 1 by 40. So then once we got the number of moles, then again we know number of moles of solute is nothing but a given weight by molar mass. So then molar mass of oxalic acid is 126 gram, we calculated already. So then number of moles is 140, I keep it up over here. Then given weight is a W, I need to find out. Then W by molar mass of oxalic acid 126 I put. Then W is a given amount, how much I need to dissolve, which is nothing but a 126 by 40. Is it clear or not? Okay. Then you look at another 1-2 problem, another 2-3 process. Now you look at, if they are giving you like this, 1 kg of glucose dissolved in 2000 ml of water, and they are asking what is the molarity of solution, and provided what logic they are telling, due to addition of glucose, volume of solution is not changing. Volume of solution is not changing. So now, how we will do these things? If you look at these things very carefully, how we will do these things? Now if you look at, immediately I told you here glucose is your solute, whereas water is a solvent, and then I need to, and that only contributing the total volume of the solution, and we need to know like that number of moles of solute by volume of the solution in liter is nothing but a molarity. Now what we will do first, I will find out the number of moles of solute. If you look at number of moles of solute, means here solute is a glucose, small n is a number of moles of solute, which will be equals to given weight by molar mass. Both should be in which unit? Gram. But here they are giving in which unit? 1 kg. So that's why 1 kg will be equals to how many gram? 1000 gram. Yes or no? 1 kg will be equals to how many gram? 1000 gram. That's why 1000 gram divided by molar mass. Glucose means everybody knows C6H12O6. If you calculate molar mass, it will come 180 gram. 6 into 12 plus 6 into 16, which will give rise to 180. So that's why number of moles of solute in, that means given weight in gram, as well as molar mass of glucose, which is 180, that also should be in gram. Gram cancel out, then you will get your value like this, 100 by 80. Keep it up over here. Later you can do simplifications. So now number of moles of solute you got, then the volume of solution I need in liter. Then volume of solution V, volume of solution, this is the volume of solution. Then volume of solutions will be equals to, you look at 2000 ml. ml to liter means divided by 1000, which is nothing but a 2 liters. Then directly I will charge molarity will be equals to number of moles of solute, which is nothing but a glucose, which is 100 by 18 by volume of solution in liter, which is nothing but a 2. After that, you can do your calculations, simplifications you can do. I hope. Is it clear or not? Understood everybody? Okay. Then you look at next, another way they can give you molarity. How? Suppose the same type of, suppose two different volume of acid solution, same acid solution, but different molarity if they mix. If two different types of same base solution, different concentration, if they are mixing, what will be that molarity of resultant solution? How they will find out that things? Let us look at the discussions of that one. So now, suppose here you look at, you have a here solution 1. First you look at this solution 1, here molarity is M1, volume is V1, and number of moles of solute is N1. Another solution is there, same substance, another solution 2 is there, same substance. Here I am writing same substance, that means same solute. So same substance is there. So then immediately here molarity is M2, volume is V2, number of moles of solute is N2. Now here directly I can write down molarity will be equals to number of moles of solute by volume of solution in liter. Here directly it is there in liter. Same way, molarity here will be equals to number of moles of solute by volume of solution in liter. Now whenever these two solutions with of same substance solution we are mixing, and here I am asking the resultant molarity of solution. Whenever I am going to discuss that resultant molarity, calculate resultant molarity, then what do we have to do? Resultant molarity represented by MR, molarity resultant, which will be equals to total moles of solute by total volume of the solution. Total moles of solute by total moles of solute by moles of solute by total volume of solution. Total volume of solution, both are there in liter. Total volume of solution. So that's why no problem. Both are here. This is also there in liter, and this V2 also is in liter. That's why there is a no problem. So then total moles of solute, how we were doing, then here itself I am writing these things, this part. Then MR will be equals to total moles of solute means here N1 and here N2. So that's why N1 plus N2 by total volume of solution. Here V1 volume is there, here V2 volume is there. That's why total volume of solution V1 plus V2. Again you look at instead of N1, what I can write down? M1 into V1 because they are present in a cross multiplication relation. So then that's why MR equals to M1 V1. Same way N2 equals to M2 V2 by V1 plus V2. I am writing V total volume. So this is the formula we are derived whenever same type of substance, that means same solute, but they have in a different concentration to different solution. Whenever you are mixing, then resultant molarity of the solution, how we can calculate? Total moles of solute by total volume. Total moles, how I am exchanging? Here instead of N1, M1 V1. Here instead of N2, what I put? M2 V2. Then we got the formula resultant molarity of the solution for same type of substance when you are mixing M1 V1 plus M2 V2 by V total. Is it clear? So now if two different type of substance is there, two different types of substance different type of substance means reacting substance like acid mixed with like HCl mixed with NaOH. HCl, this example is like one concentration of HCl mixed with other different concentration of HCl with a different volume. So that is called same type of substance. Two different type of substance means reacting substance. Suppose you are mixing HCl plus NaOH. So that means they are reacting to each other. That time for these two different type of substance means reacting substance. That means one is consuming other substance. That type of scenario. Then that type of resultant molarity discussions. MR will be equals to M1 V1 into M2 V2 by V total. Condition if M1 V1 is greater than M2 V2. What molarity, what volume they will give, directly if you multiply it, that will give you M1 V1. And then another also possible MR resultant molarity will be equals to like acid and base you are mixing. Based on the situation, overall solution will be acidic. If acid is excess than base, then overall solution will be acidic. If base is excess than acid, then overall solution will be basic. And what is that resultant molarity? We can calculate like this way. If acid and base are equal, then solution will be neutral. One thing will be fully consumed the other things. So now here MR will be equals to, so M2 V2 minus M1 V1 divided by V total. Condition is, what is the condition? Condition is M2 V2 should be greater than M1 V1. So that means whenever same type of substance is mixing, resultant molarity M1 V1 plus M2 V2 by V total. Now whenever two different types means reacting, one will react with the other, that type of situation is coming like acid and base. So then that time resultant molarity will be equals to, depending on which thing is excess, the nature of solution will be like that. It can be acid, it can be base. Then resultant molarity will be M1 V1 minus M2 V2 by V total if M1 V1 is greater than M2 V2, or otherwise resultant molarity will be equals to M2 V2 minus M1 V1 by V total. Condition M2 V2 will be greater than M1 V1. Whatever you can, as your choice, you can take acid solution, you can take M1 V1, basic solution you can take M2 V2, or you can take basic solution M1 V1, acid solution M2 V2, is your choice. Is it clear? So let us look at this type of problem discussions, and then you will get a full clarity of molarity. Okay now? Let us go with the next slide. So they will give like this problem: 100 ml of 0.1 molar HCl solution mixed with 100 ml of 0.2 molar HCl solution. Suppose here if they give H2SO4, they never cannot be asked that resultant molarity. Both the solute will be same like HCl. Okay. So now 100 ml of 0.1 molar HCl solution mixed with 100 ml of 0.2 molar HCl solution. But if they, instead of one HCl, if they give H2SO4, they can ask resultant molarity of H plus, because H plus part is a common for both of the substance. That type of problem also we will discuss. So now 100 ml of 0.1 molar HCl is mixed with a 100 ml of 0.2 molar HCl solution. Then we will go with a millimole approach. What is millimole approach? You look at, you can go with a molarity directly approach. That formula we can charge over here, but that is a millimole. That millimole means whenever I told you, if you look at here directly, I can go with that formula, and that I will explain how it is coming in a millimole approach. So that means resultant molarity, what I told you, my dear student, tell me. So this is, I am taking my V1. Is your choice, you can take V2. So I am taking, this one is V1 and this one is your M1. This one is my V2 and this one is my M2. Then same type of substance, non-reacting. So then resultant molarity will be equals to what formula we derive? M1 V1 plus M2 V2 by V total. We will apply that one. You look at M1 V1 plus M2 V2 by V total, total volume of the solution after mixing. So now if you look at over here, M1 V1, you do it. M1 is 0.1, V1 is 100 plus M2 is 0.2 and V2 is also 100 divided by total volume V1 plus V2, that means 100 plus 100, which is nothing but a 200. Now you look at, so immediately you are getting, this is 10 plus this is nothing but a 20 by 200, which is nothing but a 30 by 200, which is nothing but a 3 by 20. After that simplifications you can do. This is your resultant molarity. As or no? So some student are thinking, sir, here you are not converting the volume in liter. You look at here, that what fantastic thing is happening. I just teach you, molarity also can be defined as number of millimole of solute by volume of solution in ml. Volume of total solution, volume of solution in ml, that also give you molarity. This is called millimole approach. Why? Because millimole is nothing but a what? You look at, my dear, millimole is nothing but a ml into molarity. Okay na? And volume of solution in ml, total volume is that. Then ml cancel out, directly I will get the value of what? Molarity. That's why that only happening over here. No need to convert. ml into molarity, molarity into volume of the solution in liter is a number of moles. Molarity into volume of the solution in ml is what? Millimole. So that's why you look at, whenever I am multiplying these and these, 100 ml into 0.1 molar, I am getting this 10 millimole of this one. Plus, whenever 100 into 0.2, we are getting a 20 millimoles of other HCl. So then 10 plus 2 is 30 millimole by total volume. 100 plus 100 is a 200 ml. So then millimole by total volume of the solution in ml. Same situation. You look at ml into molarity is a millimole by volume of the solution in ml. ml cancel out, directly we got the molarity values. That's why no need to convert in what? Liter. Is it clear? But whenever that one reacting species is there, then we have to do which formula? Based on the situation. Let us take another problem like this. Suppose here I am taking 100 ml of 0.1 molar HCl solution mixed with 200 ml of 0.2 molar NaOH. Now they are asking resultant molarity of the solution. Now you look at, suppose if I am taking, this is my V1 and this is my M1, this is my V2, this is my M2. You can do by your choice. First one also you can take V2, M2, V1, M1. It's your choice, my dear. I did it like this. Now I have to check what is M1, V1 value is coming. As I took this acid is a M1, V1, then M1, V1 is coming 100 into 0.1, which is nothing but a 10. What is M2 V2 value is coming? I took the base is M2 V2, which is 200 into 0.2. 200 into 2 is a 400. Decimal point 1 is there. That's why 200 into 0.2, which is nothing but a 40. You look at the situation. So, whereas my base is 40 millimole, acid is 10 millimole, then who is excess? Base. That's why overall solution will be basic in nature, and that represent the molarity of OH minus, base only. So that's why resultant molarity will be equals to, here what I have to do, M2V2 is greater. That's why M2V2 minus M1V1. Why? Acid base means one reactant is consuming the others. Yes or no? So that's why M2V2 minus M1V1 by V total. Why? Here the logic is M2V2 is greater than M1V1. If M1V1 greater, then I will do M1V1 minus M2V2. In that condition, M1V1, if it is acid, then my overall solution will be acidic in nature. So that's why M2V2, which is nothing but a 40 minus 10 divided by total volume of the solution, which is here 100 and 200, which is nothing but a 300, which is nothing but a 30 by 300. You can do this calculation, my dear. As or no? Further simplifications you can do. So now I show you reacting, non-reacting both cases. But keep in mind one thing, whenever there is the N factor, that means basicity of the acid and acidity of the base are same. We will discuss in equivalent concept. Then only I can charge this formula. If they are not same, this formula will not give you the right result. That kind of problem also we'll discuss after normality discussions. So now let us look at another model of molarity discussion, and then I will bind up these molarity discussions. Suppose if I am telling you have a 100 ml of 0.1 molar H2SO4 solution, and in this solution you are adding plus 100 ml of water you are adding. Then what will be my final molarity or resultant molarity will be how much? That is the final molarity or resultant molarity will be how much? That is the questions. That means whenever in a particular concentrated solution, when we are adding water, then what is happening? Number of moles of solute is not going to change. Then what is changing? My volume of the solution is increasing. And what is the relation, my dear? If molarity equals to number of moles of solute by volume of the solution. If volume of the solution is increases, molarity will be what? Decreases. Natural fact. Your denominator increasing, overall value will be what? Decreasing. So that's why this volume of the solution increases. Why? Because I am adding more water. That means solution getting what? Diluted. So this is a case of dilutions. This is a case of dilutions. Whenever there is a case of dilution is there, molarity will change because of the volume increment or volume changes, not because of the solute changes. So that's why whenever there is a case of a dilution, there is a molarity change just because of volume of the solution is changing, not because of the solute is changing. Before dilution, whatever the number of moles of solute, after dilutions, the number of moles of solute both are same, only molarity is changing due to change of the volumes. Now if you look at before, if I am asking before molarity was there, I am telling M1, which is nothing but a number of moles of solute N1 by volume of the solution in liter is nothing but I am telling is V1. Now after dilutions I am telling your molarity is M2, then number of moles of solute is same by volume of the solution now is V2. This is before dilutions situation, and this is after dilution situation. Yes or no? Dilution situations. Now if you look at, then what I can write down, then N1 equals to M1 V1, again my N1 equals to M2 V2. That means what I can write down, in case of a dilutions, I can write down directly M1 V1 equals to M2 V2. Yes or no? So M1 V1 will be equals to M2 V2. Why? Number of moles of solute is both representing M1 V1 as well as M2 V2. That means number of moles of solute is not changing due to dilution. What is changing? Volume is changing. That's why overall molarity is decreasing. So that's why if you look at here, why we equate M1 V1 equals to M2 V2? Because both representing the number of moles of solute before dilution and after dilution. As the number of moles of solute is not changing, that's why we are equating M1 V1 equals to M2 V2. And then here some student are thinking, sir, ml, I no need to convert here. Here also I have a ml means what? ml to liter means that ml value divided by 1000. Here also ml value divided by 1000 will cancel out. So no need to. If you wish, you can do, but there is no need for that one. This is basic mathematics. Both the side that interconversion is present, directly 1000 will be cancelled out. So that's why if it is given in liter, if it is given in ml, whatever you need not to worry for that. You need directly, you will charge M1 V1 equals to M2 V2. So then if you look at directly, what is my M1? Initially my M1 was there, molarity was there 0.1. Initial volume was there 100 ml. Then final molarity M2, I need to find out which they are telling MR, resultant molarity. Final volume of solution will be how much? 200, because 100 ml acid solution, 100 ml water they are adding. Then I will charge that formula M1 V1 equals to M2 V2. That means 0.1 into 100 will be equals to M2 into 200. Now you look at M2 will be equals to final molarity 0.1 into 100 by 200. So then these things is coming like this. This 0 cancelled. This 0 is cancelled over here. So here 0 is cancelled. So now we are getting 1 by 20. So then 1 by 20 will be equals to 0.05 molar. You look at, that means my final molarity is coming 0.05 molar. That means the resultant molarity value is 0.05 molar. Is that clear to everybody? So that means what I did before dilution, what is the situation of a number of moles of solute. After dilutions also number of moles of solute are same. I am just equating that things by molarity into volume. And then once we equate, initial molarity volume given, final volume we know, final molarity we need to calculate from that equation. That only I did. Yes or no? Is it clear to everybody? Okay. Thank you very much. Keep on watching. One by one, everything will come into this channel. Thank you very much. Have a good day.